What's up, folks? It's Mr. Walker here, coming to you with our next lesson. We are talking about measuring angles. We did a little bit of this when we did our introduction to angles, but we're going to be digging into this a little more for the algebra end of this. So, first off, let's talk about the protractor postulate. Just like how the ruler postulate was able to help us set up equations for different line segments, the protractor postulate is going to help us set up for different angles. So, it says let OA and OB be opposite rays. Okay, so OA and OB, those are on the bottom of this protractor. And then all the rays with the endpoint O can be paired with real numbers from 0 to 180. So going into this, what we have here is this whole protractor represents this huge angle from A to B. Okay, it goes from A to the middle of O, then over here to B. Now, we're dealing with the angles. So everything that has a ray that goes from O up to another different point, that sets up another angle that we have. Now, all these angles from this side to this side add up to 180. So if OA is paired with O, OB is paired with 180. If OC is paired with X and OD is paired with Y, then what this will do is this will let me know that this right here, COD, is a result of subtracting this X and this Y. Now, if we actually go through and take all the information that we have, look at your protractor. If I'm talking about that from here to here, from here to here is what we're trying to measure, I can count the amount of spaces in between it, or I could subtract the values on the protractor from each other, and then I'll end up getting the actual measurement of this angle. It's just like when I gave you a ruler and I say from point C to point A is uh, this many spaces, and then point C to point D is this many spaces. You can just count the spaces all together. Okay. So, really using the protractor, we can just use the numbers that are on there to set up equations to find different angles. Okay. So, all the protractor postulate is just helping us to set up for different angles. Most of the angles that we're going to be dealing with are not going to be bigger than 180 for this part of our curriculum. Okay, it's not really doesn't get really big until we deal with like circles, and circles are 360 degrees, but that's not really anything we got to worry about until like May. So let's talk about how this relates to some more operations. So along with the protractor postulate, just like how we had with the ruler postulate, we have a postulate that sets up for addition. So the angle addition postulate goes as the following. If Q is on the interior of this angle, MNO, so here's our big angle, MNO, here's Q here. What we have here is two angles that can be set up. One of them is over here in magenta with MNQ. The other one we have is blue with ONQ. These two angles both add up to give us this big angle with MNO over here in purple. So essentially, if I have these angles inside of this bigger angle, I can use the information that they can give me to go through and solve for it. Now, because of this, we're not going to get hung up on what type of angle it is, what's the measurement. We're not really using the protractor per se to set up an equation. We're using the information that we know to let us know that, to let us know that we have these two angles inside of this bigger one, and using that information to find all the little parts. Takes a little bit to get used to, but we're going to have some time today. All right. So here is our first little example. We got angle ABC here. Now, this whole big angle is 116. They want us to find the measure of angle NBC. NBC is this angle over here on the side. Now, over here to the left, we see that ABN, this angle right here, is 81. So this part of the angle is 81, and I don't know what this is, but I do know what the whole thing is. I could subtract 81 from 116 to give me the other part of the angle, which is 35. So really all this is just us looking at the picture, being able to set an equation up. So reading and following the directions on this is going to be real paramount. Otherwise, you'll set your problem up a little off. All right, let's get into some more stuff. We got some practice going on here. We got some simple practice. We got some stuff with algebra coming in. Remember, I told y'all algebra is going to be coming all through geometry. So don't think that we're done with it yet. All right. So I want you to try out these angles, set them up, solve them as you need, and good luck. Come back after you finish pausing it. What's up, folks? I hope that you paused it as opposed to just going through and looking at the issues. So let's go through and try it out. All right, over here, they want us to find the measure of BCE. So first, look at your letters, figure out what angle you're looking at. BCE is going from B to C to E. That means that we're talking about the whole thing, baby. That means that we got to take these two parts to add to the whole. So 73 and 13 give us 86. And that's it. Nice and good. All right. Now, this one was simple. We already knew what the parts inside were. We knew exactly what they were. We could just add them. Sometimes we have some algebra popping off. So let's look at the next one. Next one we got here, we're finding the measure of angle JKL. If this is what our JKL is, 17x plus 8. If JKY is 42, and if YKL is 12x minus 4. So first off, where's JKL? You got to make sure you identify it. JKL is this whole big angle, okay? So the whole thing equals 17x plus 8. The two smaller parts are our 42 over here at JKY and our other one with YKL at 12x plus 4. Now, you're not going to assume anything other than what they tell you. You're not going to say that this looks like a right angle because it looks like one. It's not the point. If they don't indicate it to you in any way, you're not going to assume stuff. So let's take what we got. Let's set it up. All right. First off, I know that the whole thing, 17x plus 8 equals the 42 plus 12x minus 4. I start combining my like terms, which is how I get 38 with this 12x. Now I bring all my x's to one side, all my constants to the other. So I took the 8 and subtracted it. I took the 12x and subtracted it. That's how I end up getting to 5x equals 30. I then have to take both sides and divide them by 5, which is how I get x equals 6. But is it asking for x or is it asking for something else? Nope, it's asking for something else. So we need to take this x that we just found and run it back into our calculation for JKL. So JKL is 17x plus 8. So that means I do 17 times 6 plus 8, which gives us 110. So you need to be able to set that stuff up to go through and knock it out. All right. Now we got two on the bottom here. We got one with just some regular numbers, one with some algebra popping off. So let's look at this regular one. They want us to find the measure of angle XWY if VWY is 109. So VWY is the whole big angle here. So that whole thing is 109. We're trying to find the smaller angle, but I do know that the other small angle is 79. So I could take 109 and subtract 79, and that'll give me what this is. So when I go through and do that, I get 30. Nothing big, okay? Just like how we had with up here. This was nice and simple. We can just kind of eyeball it, figure it out. YOLO, okay? Now, what about this? We got a lot of angles popping off here. Stuff's going kind of crazy, dog. So let's get into it. First off, they say that the measure of EFZ is 10x. EFZ is the small angle, so that's 10x. They say EFG is 145, so the whole big angle is 145. And then GFZ is 2x plus 13. So they want us to find GFZ, this last angle. So this is the smaller angle here. Things that you can use to your advantage is just the information. I know that the whole angle that these two are inside of is 145. So whatever this angle is cannot be bigger than 145. Okay, that's a no-no. So let's go through and set up some stuff. I know everything adds up to 145, so I take the 10x and the 2x plus 13, set it equal to 145. I start combining my like terms. That's how I get that 12x. I subtracted 13, so that's how I get down to y'all. And then I divide both sides by 12, giving me 11. And I'm done. Or am I? No, I got to go back and figure out what GFZ is. Now, I want to make sure that you recall, look at the directions, because if you don't see that you're looking for GFZ and you stop here at just what X is, you're not going to get the answer right. That's not everything. So GFZ is 2 times 11 plus 13, which gives us 35. That would be the end of that answer. All right. We got two more practice problems. So let's run through those and get it. Over here, we got finding the measure of angle RST. So RST is on this protractor. That is this small angle here. Okay. You can use what we have inside of these angles so that we can go through to subtract and figure out how big this is. So this side here is about 150. This one is a little bit bigger. This is about 81, it looks like. So you would do 150 minus 81, or you could do 50 minus 81, and that will give you what that angle is. Now, if you're like me, you just made a quick pitfall. You want to make sure that you actually use the numbers from the same area. So either using the top row entirely or the bottom row. In cases like this, and you're using a protractor to look at angles that aren't necessarily flat like this, you can line it up and just subtract the numbers that are there to find what the angle's measure is. Just make sure that you're a little careful with it. All right, now we're going to use this picture to find the measure of each angle. Things to note, these two arcs mean that these two angles are the same. This 71 is inside of this smaller angle here, BAC or CAB. So that means this is 71. And this angle here from CA to M is 90. So you can take of all those things to find out our different parts. All right, first one we're looking for is BAM. BAM is this other small angle next to 71 that makes up 90 degrees. So I could just do 71 and subtract that from 90, showing me that this other angle here is 19. Next one they want CAR. CAR is this whole straight line. Straight lines are always going to be 180 degrees because those are straight angles. Then we got MAR. MAR here is next to this right angle and adds up to the 180, which means that this side here is 90 also. Now, if this side is 90, this whole side here, and these two angles are the same, we got TAR and we got MAT. They're both the same and they both add up to 90, which means that this is really a 45-degree angle because you could just take these two and divide 90 by 2 to get that. Last one we got is BAT. So that's from B here to A to T. I already know the two parts that are inside of it. BAM was 19. Then we got TAM, which is the same as TAR being 45. So 19 and 45 add up to 64. And now we're done. Thanks for showing up, folks. And I might catch you on the flippity flip. Make sure it gets into your book. Catch you later.